What if I told you that the vast majority of the universe is made up of something we can't see, can't touch, and can't even detect with our most advanced tools? Dark matter, this invisible, mysterious substance, makes up a staggering 85% of the universe's mass. Yet, it's completely hidden from us, like the ghost of the cosmos, silently shaping the galaxies, stars, and planets we observe. It's one of the greatest enigmas in modern science, and despite decades of research, we still don't fully understand what it is. But what if everything we think we know about dark matter is wrong? What if the answers lie in ideas so unconventional they challenge the very foundations of our understanding? In this video, we'll explore 30 uncharted theories on dark matter, ideas that defy traditional thinking and could revolutionize how we see the universe. From mind-bending concepts to bold new perspectives, we're about to take a journey through the unknown. Ready to question what you thought you knew? Let's dive in. In the 1930s, Swiss astronomer Fritz Zwicky peered into the cosmos and noticed something strange. While studying the Coma galaxy cluster, he found that the galaxies were moving far too quickly to be held together by the visible matter alone. It was as if there was an invisible force at play, something unseen yet undeniably present. Zwicky called it Dunkelmaterei, dark matter, a term that would echo through the halls of astrophysics for decades. But it wasn't until the 1970s, when Vera Rubin meticulously mapped the rotation curves of galaxies, that the true scale of this mystery became clear. Rubin's work showed that stars at the edges of galaxies were orbiting just as fast as those near the center, defying Newtonian physics, the only explanation. A vast, unseen halo of dark matter surrounding each galaxy, anchoring it with its gravitational pull. Today, dark matter is understood as a mysterious substance that makes up roughly 27% of the universe's total mass energy content. Unlike ordinary matter, it doesn't emit, absorb, or reflect light, making it invisible to our telescopes. It interacts with the universe in only one way, through gravity. Yet, despite decades of research, dark matter remains an enigma. Conventional theories, like the idea of weakly interacting massive particles or WIMP, have struggled to fully explain its nature. These particles, if they exist, have eluded every detection experiment so far, leaving scientists scratching their heads. The limitations of these theories are stark. They can't account for all the observed gravitational effects, nor do they explain why dark matter seems to distribute itself in such specific patterns across the cosmos. Imagine the universe as a grand cathedral with dark matter as its invisible scaffolding. It's the hidden framework that holds everything together, shaping galaxies, clusters, and the large-scale structure of the cosmos. Without it, the universe as we know it would simply collapse. But here's the twist. This scaffolding doesn't behave like anything we've ever seen or touched. It's a cosmic phantom, defying our attempts to pin it down, and that's where things get really interesting. Because if our conventional theories can't fully explain dark matter, what other possibilities are out there? What if dark matter isn't just a single type of particle, but something far more complex, or even something that challenges the very laws of physics as we understand them? The answers might lie in theories that dare to think beyond the ordinary, and that's where our journey truly begins. What if everything we think we know about the forces shaping our universe is incomplete? This is the bold question at the heart of the first theory we're exploring: dark matter as a fifth fundamental force. While the standard model of physics has long described four fundamental forces: gravity, electromagnetism, and the strong and weak nuclear forces, some scientists are now proposing that dark matter might not be a particle at all, but rather a manifestation of something entirely new. A fifth force hidden in plain sight could be the key to solving some of the universe's most puzzling mysteries. This idea challenges the very foundation of modern physics. If dark matter is a force rather than a particle, it could explain why we've never directly detected it despite decades of searching. Instead of looking for elusive particles, we might need to rethink how gravity and other forces behave on cosmic scales. For example, recent observations of galaxy clusters have revealed gravitational anomalies that don't quite align with our current understanding. The way these clusters rotate and interact suggests that something, perhaps this fifth force, is at play, subtly altering the rules we thought we knew. Picture this: gravity as we understand it might work perfectly well on the scale of planets and stars, but what if it operates differently in the vast emptiness of intergalactic space? What if dark matter is the fingerprint of this new force, bending the fabric of the cosmos in ways we're only beginning to grasp? It's a radical shift in perspective, but one that could unlock answers to questions that have stumped scientists for decades. As we wrap our heads around this groundbreaking idea, it's worth noting that this theory doesn't just challenge the standard model, it opens the door to an entirely new way of thinking about the universe. And if dark matter is a fifth force, what other surprises might be hiding in the quantum realm? That's where our next theory takes us, diving into the tantalizing possibility that dark matter and quantum mechanics might be deeply intertwined. What if the mysterious nature of dark matter is intertwined with one of the most baffling phenomena in quantum physics: entanglement? This theory suggests that dark matter might not just be influenced by gravity, as we've long assumed, but could also operate on principles that defy classical physics. Quantum entanglement, where particles become interconnected and instantly affect each other regardless of distance, might hold the key to understanding dark matter's behavior on a cosmic scale. Imagine the universe as a vast quantum computer, with dark matter acting as its hidden code, a silent, invisible force orchestrating the cosmos in ways we're only beginning to glimpse. Experiments like those conducted at the Large Hadron Collider are probing this connection, searching for signs of quantum effects within dark matter. Scientists are asking whether entangled particles could be the bridge between the visible and invisible realms, influencing how dark matter clumps together or interacts with galaxies. If this link exists, it would revolutionize our understanding of the universe, suggesting that dark matter is not just a passive participant but an active player in the quantum fabric of reality. This idea opens up a world of possibilities, hinting that dark matter might operate on scales and principles we've yet to fully comprehend. It's a reminder that the universe often hides its most profound secrets in the smallest and strangest places. And speaking of secrets, what if dark matter's influence extends even further, into the very fabric of time itself? That's where our next theory takes us. What if dark matter isn't just a passive player in the cosmos, but a force that shapes the very fabric of time itself? This intriguing idea brings us to our third theory, the connection between dark matter and the arrow of time. In physics, the arrow of time refers to the one-way direction in which time flows from past to future, governed by the principle of entropy, the natural tendency of systems to move toward disorder. But what if dark matter is influencing this flow, bending the rules we thought were universal? Imagine dark matter as a cosmic clockmaker, subtly adjusting the gears of time. Some scientists propose that its mysterious properties could be interacting with the universe in ways that challenge our understanding of causality. For instance, dark matter's gravitational influence might not just hold galaxies together, it could be shaping the very direction of time's arrow. This could help explain some of the most perplexing paradoxes in cosmology, like why the universe is expanding at an accelerating rate. If dark matter is indeed altering the flow of time, it might provide a missing link in our understanding of how entropy and cosmic expansion are intertwined. But how does this work? Think of the universe as a giant clock with dark matter as the mechanism that keeps it ticking. Without dark matter, time might not flow in the same linear way we experience it. This theory opens up a fascinating possibility. That dark matter isn't just a component of the universe, it's an active participant steering the course of time itself. And if that's true, it could redefine how we think about everything from the Big Bang to the fate of the cosmos. This leads us to an even more radical idea. What if dark matter isn't just a force or a particle, but something far more dynamic? Our next theory takes this concept to the next level, suggesting that dark matter could be a living entity, interacting with the universe in ways we're only beginning to imagine. What if the universe isn't just a vast, lifeless expanse, but something far more extraordinary? Picture this: dark matter, the mysterious substance that makes up most of the cosmos, might not be inert or passive at all. Instead, it could be a form of cosmic life, a living, evolving entity with its own rhythms and processes. This is the bold idea behind Theory 4, which proposes that dark matter could function like a kind of cosmic organism, complete with its own metabolism and even a form of evolution. Think of it this way: just as living organisms on Earth consume energy, grow, and adapt over time, dark matter might interact with its environment in ways we can't yet fully grasp. Some scientists speculate that dark matter could play a role in maintaining the cosmic balance, almost like the universe's immune system. It could be regulating the distribution of galaxies, influencing the expansion of space, or even responding to changes in the cosmic environment. This theory blurs the line between physics and biology, suggesting that the universe itself might be more alive than we ever imagined. But how could something as abstract as dark matter possess qualities of life? The key lies in redefining what life means. On Earth, life is based on carbon and water, but in the vastness of space, the rules might be entirely different. Dark matter could operate on principles we haven't yet discovered, using mechanisms that defy our current understanding of biology and physics. It's a mind-bending idea, one that forces us to rethink not just the nature of dark matter, but the very definition of life itself. This theory also raises an intriguing question. If dark matter is a cosmic organism, could it have a form of consciousness? Could it be aware of its surroundings in some way? While this might sound like the plot of a science fiction novel, it's a question that some researchers are beginning to explore, and that leads us to our next theory, which dives into the even more speculative idea of dark matter's potential connection to consciousness. What if the mysterious substance we call dark matter isn't just a cosmic enigma, but something far more intimate, something tied to the very essence of thought itself? This is where Theory 5 takes us, into the intriguing intersection of dark matter and consciousness. Imagine for a moment that dark matter isn't just a passive observer in the universe. Instead, it could be the invisible medium through which our thoughts and reality intertwine. This idea pushes the boundaries of physics into the realm of philosophy, suggesting that dark matter might act as a bridge between the mental and the material. Think about it. If dark matter permeates everything, could it also be the fabric of the mind, the hidden layer that connects our inner world to the outer universe? This theory challenges the traditional materialist view, which assumes that consciousness is merely a byproduct of physical processes in the brain. Instead, it opens the door to a radical possibility that dark matter could be the missing link, the conduit through which thoughts influence reality. To explore this, let's try a simple thought experiment. Picture dark matter as an unseen network, a web that not only holds galaxies together, but also connects minds across the cosmos. Could it be that every thought we have ripples through this network, subtly shaping the fabric of reality? While this idea might sound like science fiction, it's a fascinating blend of physics and metaphysics, forcing us to rethink what we know about both the universe and ourselves. This theory doesn't just challenge materialism, it invites us to consider a universe where the boundaries between mind and matter are far blurrier than we ever imagined. And as we ponder this, another question emerges. What if dark matter isn't even a physical substance at all? This leads us to our next theory, where dark matter takes on an even more mind-bending form, a holographic projection, a cosmic illusion that redefines everything we thought we knew about the universe. What if the dark matter we've been searching for isn't even part of our universe? Theory 6 introduces a mind-bending possibility. Dark matter could be a holographic projection from a higher dimensional reality. This idea stems from the holographic principle, a concept in theoretical physics suggesting that all the information in a volume of space can be represented as a hologram on its boundary. In simpler terms, it's like imagining our universe as a three-dimensional movie, with dark matter acting as the hidden projector behind the scenes. This theory offers a fascinating solution to some of the inconsistencies in dark matter observations. For instance, if dark matter is a projection from a higher dimension, it could explain why it doesn't interact with light or ordinary matter in the ways we'd expect. It's as if we're only seeing the shadow of something much more complex, something that exists beyond the boundaries of our three-dimensional perception. The holographic principle has already been used to explore black holes and quantum gravity, so applying it to dark matter isn't as far-fetched as it might sound. It opens the door to a universe where the fabric of reality is far more intricate than we've ever imagined. But if this theory leaves you questioning the very nature of existence, wait until you hear what comes next. Some scientists believe dark matter might not even belong to our universe at all. It could be a leftover remnant from a completely different cosmic era, a previous universe that existed before our own. What if dark matter isn't just some mysterious substance lurking in the shadows of our universe, but rather a cosmic fossil, an ancient relic from a time before the Big Bang itself? This is the bold idea behind Theory 7, dark matter as a cosmic fossil. Imagine dark matter as a kind of echo, a faint whisper from a universe that existed long before ours. It's a concept that turns our understanding of the Big Bang on its head, suggesting that our universe might not be an isolated event, but part of a much larger, interconnected multiverse. This theory raises fascinating questions. Could dark matter be the leftover remnants of a previous cosmic cycle, a kind of cosmic memory encoded into the fabric of our universe? If so, it would mean that the Big Bang wasn't the absolute beginning, but rather a dramatic moment of transition, a bridge between an older reality and the one we inhabit today. Think of it like this: if the Big Bang was the birth of our universe, dark matter might be the DNA passed down from its cosmic ancestors. It's a hauntingly beautiful idea, one that challenges us to rethink not just the nature of dark matter, but the very origins of existence. And if this theory holds true, it could open the door to understanding the multiverse. If dark matter is indeed a relic from a pre-Big Bang universe, it might carry clues about other universes that exist beyond our own. It's like finding an ancient artifact that hints at a civilization we never knew existed. This cosmic fossil could be the key to unlocking secrets about the broader multiverse, a tapestry of universes woven together in ways we're only beginning to imagine. But what if dark matter's role goes even further? What if it's not just a relic, but an active participant in the creation of universes? That's where our next theory takes us, exploring how dark matter might be the architect of cosmic structures, shaping the birth of entire universes. It's a mind-bending possibility that pushes the boundaries of what we think we know about the cosmos. What if dark matter isn't just a hidden force in our universe, but the very architect of countless others? This is the core idea behind Theory 8, which proposes that dark matter could act as a cosmic seed, birthing entirely new universes. It's a mind-bending concept that reshapes how we think about the life cycle of the cosmos. Instead of viewing our universe as a static, isolated entity, this theory suggests it might be just one of many, sprouting from the fertile ground of dark matter. Imagine dark matter as a cosmic gardener, scattering seeds across the vast fields of existence. Each seed could grow into a new universe, complete with its own unique laws of physics and dimensions. This idea challenges the traditional view of a single, unchanging universe and opens the door to an ever-expanding multiverse. It's a radical shift in perspective, one that suggests dark matter isn't just a passive player in the cosmic drama, but an active creator of reality itself. But how could this work? Some scientists speculate that dark matter might contain pockets of energy or information that trigger the formation of new universes under the right conditions. These universes could exist alongside ours in ways we can't yet detect, hidden in dimensions beyond our perception. It's a theory that blurs the line between science and philosophy, inviting us to rethink not just the nature of dark matter, but the very fabric of existence. This leads us to the next fascinating idea. What if dark matter isn't just matter, but a form of energy, a force that powers the birth of universes and shapes the structure of reality itself? As we explore this next theory, we'll dive into the possibility that dark matter could be far more dynamic and far more mysterious than we've ever imagined. What if dark matter isn't matter at all? That's the radical idea behind Theory 9, which suggests that dark matter might actually be a form of pure energy. This theory flips the script on everything we think we know about the universe's invisible scaffolding. Instead of being composed of particles, dark matter could be a vast reservoir of energy woven into the fabric of space itself. Imagine the universe as a giant machine and dark matter as its hidden battery, quietly fueling the expansion of the cosmos. This energy-based perspective could explain why dark matter doesn't interact with light or ordinary matter in the way we'd expect. It's not something we can touch or see. It's something we feel through its effects on the universe's growth. The implications of this idea are staggering. If dark matter is pure energy, it could provide a new explanation for the accelerating expansion of the universe. Instead of relying on dark energy as a separate force, dark matter itself might be driving the cosmic push outward. It's a concept that challenges the very definition of matter and forces us to rethink our understanding of what makes up the universe. But this isn't the only bold reimagining of dark matter. Up next, we'll explore an even more mind-bending idea. What if dark matter isn't a substance or energy at all, but a vast cosmic network connecting everything in the universe? Stay tuned. What if dark matter isn't just scattered throughout the universe like isolated clouds, but instead forms an intricate, sprawling network, a cosmic web that connects everything? This is the heart of Theory 10, the idea that dark matter isn't just passively lingering in space, it's actively shaping the universe on the grandest scale. Imagine dark matter as the universe's nervous system, a vast, invisible network that transmits information and influences the distribution of galaxies across unimaginable distances. This theory aligns with what we've observed in the cosmic web, a filamentary structure of galaxies and gas that seems to trace the outlines of something much larger, something unseen. Scientists have long noticed that galaxies aren't randomly scattered. They're arranged in a web-like pattern with clusters and voids that suggest an underlying framework. If dark matter is the backbone of this structure, it would explain why galaxies form along these filaments, almost like beads on a string. But here's where it gets even more fascinating. This cosmic web isn't just a static map. It's dynamic, evolving, and possibly even communicating in ways we're only beginning to understand. Dark matter, in this view, isn't just an invisible mass, it's the architect of the universe's large-scale structure, guiding the flow of matter and energy across billions of light years. This theory also challenges the traditional idea of dark matter as isolated clumps or halos surrounding galaxies. Instead, it suggests that dark matter is interconnected, forming a continuous network that binds the cosmos together. It's a shift in perspective that could redefine how we think about the universe's evolution and our place within it. And if dark matter truly is this cosmic web, what else might it be capable of? Could it hold the key to understanding the universe's most mysterious phenomena? Speaking of mysteries, this brings us to another compelling idea: the potential connection between dark matter and black holes. Could these enigmatic structures, often thought of as cosmic vacuum cleaners, actually be linked to the dark matter web? Let's explore that next. What if dark matter isn't just a mysterious substance filling the cosmos, but also a cosmic fuel source for some of the universe's most enigmatic objects? This brings us to Theory 11, the idea that dark matter and black holes share a symbiotic relationship. Picture dark matter as the invisible feedstock that feeds the insatiable hunger of black holes, allowing them to grow into the supermassive giants we observe at the centers of galaxies. In return, black holes might influence the distribution and behavior of dark matter, creating a dynamic interplay that shapes the universe on a grand scale. This theory offers a compelling explanation for how supermassive black holes could have grown so quickly in the early universe. Without dark matter acting as a steady supply of energy, it's hard to account for their rapid expansion. At the same time, the gravitational pull of black holes might help corral dark matter into the dense halos we detect around galaxies. It's a cosmic dance of give and take, where one mystery feeds another, and together they sculpt the structure of the cosmos. But what if this relationship is just the tip of the iceberg? What if dark matter isn't just a passive participant in this dance, but something far more fundamental? This leads us to the next mind-bending theory, one that suggests dark matter might not be a thing at all, but a manifestation of time itself. Could time, in some strange way, be the key to unlocking the secrets of dark matter? Let's explore this fascinating possibility next. What if dark matter isn't just a mysterious substance, but something far stranger, a remnant of time itself? This is the bold idea behind Theory 12, dark matter as frozen time. Imagine time as a river constantly flowing forward, carrying everything in the universe with it. But what if some parts of that river froze? What if dark matter is like a snapshot of time, existing outside the usual flow, holding moments in a kind of cosmic stasis? This theory suggests that dark matter could be a manifestation of frozen time, a relic of moments that have been paused, preserving them in a state beyond our perception. This concept turns our understanding of space-time on its head. If dark matter is indeed frozen time, it could explain some of the biggest paradoxes in cosmology. For example, why does dark matter not interact with light or ordinary matter in the way we expect? If it exists outside the flow of time, it might operate by entirely different rules, invisible and untouchable to the forces governing the rest of the universe. Think of it like the universe's pause button, a mechanism that captures and holds moments in place, creating pockets of stillness in an otherwise dynamic cosmos. The implications of this theory are profound. It could mean that dark matter isn't just a passive observer in the universe, but an active participant in shaping the fabric of reality. By existing outside the normal flow of time, it might influence how space-time itself is structured, offering clues to the mysteries of gravity, expansion, and even the birth of the universe. And as we begin to unravel this idea, it naturally leads us to another fascinating possibility. Could dark matter also play a role in creating dimensions beyond the ones we know? What if dark matter isn't just a mysterious substance filling the universe, but something far more extraordinary, something that's actively shaping the very fabric of reality? This brings us to Theory 13, dark matter as a dimension generator. Imagine dark matter as the cosmic architect, quietly constructing hidden dimensions beyond the four we experience: length, width, height, and time. This idea isn't just science fiction. It's deeply rooted in the principles of string theory, which proposes that our universe might be woven from tiny, vibrating strings existing in higher dimensional spaces. Dark matter, according to this theory, could be the force that stabilizes or even creates these extra dimensions, explaining why it's so pervasive yet invisible to us. Think of it like this: if our universe were a book, dark matter might be the ink that writes on pages we can't see. These hidden dimensions could be curled up so tightly or exist on such a minuscule scale that we simply can't detect them directly. But their influence might be everywhere, shaping the gravitational effects we attribute to dark matter. This theory not only offers a tantalizing explanation for dark matter's elusive nature, but also bridges the gap between cosmology and particle physics, suggesting that the answers to some of our biggest questions might lie in dimensions we've yet to explore. And speaking of hidden layers, this leads us to another fascinating idea. What if dark matter isn't just matter or energy, but something even more abstract, like information itself? But let's save that for the next theory. What if dark matter isn't just an invisible force holding galaxies together, but something far more profound, a cosmic library storing the universe's deepest secrets? This is the essence of Theory 14, dark matter as cosmic information. Imagine dark matter not as a passive substance, but as an active repository, encoding the history, structure, and even the future of the cosmos. It's a bold idea that merges the worlds of physics and information theory, challenging the traditional view of dark matter as inert and unchanging. Think of it like this: if the universe were a computer, dark matter could be its hard drive, meticulously recording every event, every interaction, and every piece of data that defines existence. This theory suggests that dark matter might not just influence the universe's structure, it might also hold the key to understanding its very story. But how could something as elusive as dark matter carry such profound information? The answer lies in the intricate relationship between energy, matter, and information. In physics, information isn't just a human concept, it's a fundamental property of the universe. From the spin of particles to the motion of galaxies, everything leaves a trace, a kind of cosmic fingerprint. Dark matter, with its pervasive presence and gravitational influence, could be the medium through which this information is stored and transmitted. It's a theory that pushes the boundaries of our understanding, suggesting that the universe isn't just a collection of objects and forces, but a dynamic, interconnected system of data. This idea also raises a fascinating question. Could we one day decode the information stored in dark matter? If so, what might we learn about the origins of the universe, the fate of galaxies, or even the nature of time itself? While the practical challenges are immense, the possibility alone is enough to ignite the imagination. Dark matter, in this light, becomes more than a mystery. It becomes a gateway to uncovering the universe's hidden narrative. As we move forward, this theory invites us to rethink not just what dark matter is, but what it might represent in the grand tapestry of existence. And speaking of reimagining, our next theory takes this idea even further, proposing that dark matter might act as a cosmic mirror, reflecting the universe in ways we've only begun to explore. What if the universe we see is only half the story? Imagine a shadowy reflection, a cosmic mirror that duplicates everything we observe but remains just out of reach. This is the intriguing premise behind the idea of dark matter as a cosmic mirror, a theory suggesting that dark matter could be the universe's doppelganger, a hidden counterpart that mirrors the visible cosmos. It's not just an invisible substance, it's a parallel reality existing alongside ours, shaping the fabric of space in ways we're only beginning to understand. This theory offers a fascinating explanation for some of the strangest phenomena we've observed. Take gravitational lensing, for example. Sometimes light from distant galaxies bends in ways that don't quite match the visible mass in the area. Could it be that this distortion is caused by the gravitational pull of a mirrored version of the universe, one made entirely of dark matter? And what about the distribution of galaxies? The way they cluster and spread across the cosmos often defies predictions based on visible matter alone. A shadow cosmos could fill in the gaps, acting as a hidden scaffolding that guides the formation of galaxies on a grand scale. Think of dark matter as the universe's silent twin, always present but never directly seen. It's not just a passive observer, it's an active participant, shaping the cosmos in ways that echo our own reality. This idea challenges us to rethink what we know about the universe's structure and raises the question: if dark matter truly mirrors the visible universe, could it also hold clues about the nature of dark energy? These two mysterious forces, often discussed separately, might be more connected than we realize, and that brings us to our next theory, one that explores the potential link between dark matter and dark energy, and how they might work together to shape the fate of the cosmos. What if dark matter and dark energy aren't the cosmic strangers we've always assumed they are? What if, instead of being separate entities, they're two sides of the same cosmic coin? This is the heart of Theory 16, which proposes that dark matter and dark energy are deeply interconnected, forming a unified force that shapes the universe in ways we're only beginning to understand. For decades, scientists have treated these two mysterious components as distinct: dark matter holding galaxies together with its gravitational pull, and dark energy pushing the universe apart, driving its accelerated expansion. But what if their relationship is far more intimate? Imagine dark matter and dark energy as the yin and yang of the cosmos. Just as yin and yang are opposing yet complementary forces, dark matter and dark energy could be two expressions of a single underlying phenomenon. This theory suggests that the very fabric of the universe is governed by a delicate balance between these two forces, one pulling, the other pushing, creating the intricate dance of cosmic expansion and structure formation we observe today. If true, this could revolutionize our understanding of the universe, offering a simpler explanation for why the cosmos behaves the way it does. The implications are staggering. If dark matter and dark energy are interconnected, it could solve one of the biggest mysteries in modern physics: why the universe's expansion is speeding up. Instead of treating dark energy as an entirely separate force, this theory suggests it might emerge naturally from the same framework that governs dark matter. It's like discovering that two seemingly unrelated puzzle pieces actually fit together perfectly, revealing a clearer picture of the cosmic landscape. But this theory doesn't just challenge our understanding of dark matter and dark energy, it also opens the door to even more intriguing possibilities. What if this unified force has deeper ties to other cosmic mysteries? For instance, could it help explain why antimatter, the mirror twin of ordinary matter, is so scarce in the universe? This leads us to the next theory, which flips the script entirely by suggesting that dark matter might actually be a form of antimatter. Could the key to understanding the universe lie in the relationship between these elusive, invisible forces? What if dark matter isn't just a cosmic enigma but the ghostly twin of antimatter lurking in the shadows of the universe? This theory proposes that dark matter is the invisible counterpart to antimatter, existing in a parallel state that we can't directly observe. It's a haunting idea. Antimatter, which we know annihilates when it meets regular matter, could have a hidden companion in dark matter, balancing the scales of the cosmos. But why would this matter? Well, one of the biggest mysteries in physics is why antimatter is so scarce in the universe while dark matter seems to dominate. If dark matter is indeed the shadow of antimatter, it could explain this imbalance, offering a tantalizing clue to the universe's asymmetry. Think of it like this: imagine antimatter as a bright flame, and dark matter as the faint, flickering shadow it casts. The flame may be fleeting, but its shadow lingers, unseen yet omnipresent. This duality could be the key to understanding why antimatter seems to vanish while dark matter remains. But here's where it gets even more intriguing. Could this invisible shadow play a role in the very fabric of life itself? As we peer deeper into the mysteries of the cosmos, this theory opens the door to a new frontier: the possibility that dark matter isn't just a passive observer but an active participant in the story of existence. And that leads us to an even more profound question: what if dark matter holds the key to the origins of life? What if the very thing we've been searching for in the cosmos isn't just a mysterious force holding galaxies together, but the reason life exists at all? That's the bold claim behind Theory 18, which proposes dark matter as the cosmic catalyst for life. This theory dares to bridge the gap between physics and biology, suggesting that dark matter didn't just shape the universe, it might have sparked the very conditions necessary for life to emerge. Picture dark matter as the unseen spark that lit the flame of life, a cosmic matchstick in the vast, dark expanse of the universe. It's a radical idea, but one that opens the door to a breathtaking possibility. Life might not be a rare accident, but a universal phenomenon woven into the fabric of existence. This theory challenges us to rethink the role of dark matter entirely. Instead of being a passive player, it becomes an active force, subtly influencing the processes that allowed stars to form, planets to coalesce, and eventually life to take hold. Could it be that dark matter's gravitational effects created the stable environments needed for complex molecules to assemble? Or perhaps its interactions with ordinary matter provided the energy or stability required for life's delicate chemistry to flourish? While we don't yet have definitive answers, the implications are staggering. If dark matter played a role in life's emergence here on Earth, it could mean life exists elsewhere, thriving in the shadow of this enigmatic substance. And speaking of shadows, this leads us to an even more mind-bending idea. What if dark matter isn't just a catalyst for life, but something far more profound? What if it's a form of consciousness itself? That's where Theory 19 takes us, venturing into uncharted territory where physics meets philosophy. But more on that in a moment. For now, let's sit with the idea that dark matter might be the unsung hero of life's story, the invisible hand that guided the universe toward complexity and ultimately us. What if dark matter isn't just an invisible cosmic glue holding galaxies together, but something far more profound, something that connects not just stars and planets, but every thought, every spark of consciousness in the universe? This is the bold idea behind Theory 19, dark matter as universal consciousness. Imagine dark matter as the unseen thread that binds the cosmos, not just physically, but mentally. It's the idea that the mysterious substance we call dark matter might actually be the physical manifestation of a universal mind, a cosmic consciousness that permeates all of existence. This theory challenges the very foundations of materialism, the belief that everything can be explained by physical matter and energy alone. If dark matter is indeed the embodiment of universal consciousness, then the universe isn't just a collection of random particles colliding in the void. It's a living, thinking entity, a cosmic mind weaving the fabric of reality itself. Picture this: every star, every galaxy, every living being, connected not just by gravity but by a shared awareness. It's a concept that blurs the line between science and philosophy, suggesting that the universe might be far more alive and interconnected than we've ever imagined. But how does this idea hold up scientifically? While it's certainly speculative, some theorists argue that the properties of dark matter, its invisibility, its omnipresence, its ability to influence the universe on a grand scale, could align with the idea of a universal consciousness. It's a radical shift in perspective, one that invites us to rethink not just what dark matter is, but what it means to exist in a universe that might be fundamentally aware. Now, let's take this idea one step further. If dark matter is the cosmic mind, then what if it's also the cosmic artist? This leads us to our next theory, where dark matter isn't just connecting the universe, it's shaping it, creating patterns and structures that are as much about beauty as they are about physics. What if dark matter isn't just a mysterious force but a cosmic artist, quietly shaping the universe into a breathtaking masterpiece? This theory suggests that dark matter acts like a sculptor, molding the vast cosmic landscape into the intricate patterns we observe today. From the sprawling filaments of galaxies to the vast, empty voids in between, dark matter may be the unseen hand guiding the universe's structure. Think of it as an invisible painter, using the canvas of space to create galaxies, clusters, and the delicate web of cosmic architecture. Without it, the universe might be a chaotic, formless expanse far from the organized beauty we see. One of the most compelling aspects of this theory is how it explains the distribution of galaxies. Just as an artist uses careful brushstrokes to create depth and texture, dark matter's gravitational influence arranges galaxies into clusters and superclusters connected by threads of matter. These structures, often referred to as the cosmic web, are like the strokes of a grand cosmic painting, and the voids, those vast, empty regions of space, aren't simply blank spots. They're part of the composition, balancing the dense clusters and adding contrast to the universe's design. But what if this cosmic artistry goes even deeper? Could dark matter be responsible for the patterns we see on scales we're only beginning to understand? Some researchers speculate that dark matter's influence might extend beyond our observable universe, hinting at a connection to even larger cosmic structures, or perhaps even parallel universes. This idea leads us to the next theory, where dark matter might not just shape our universe but could also be a bridge to other realms entirely. Could dark matter be the key to unlocking the secrets of the multiverse? What if dark matter isn't just an invisible force holding galaxies together, but something far more extraordinary, a cosmic bridge to parallel universes? This bold idea, known as Theory 21, suggests that dark matter could serve as a kind of gateway, connecting our universe to countless others in a vast multiverse. Imagine dark matter as the hidden threads weaving through the fabric of reality, creating doorways to worlds we can't yet see or comprehend. This theory aligns with some of the most intriguing ideas in modern physics, particularly the concept of the multiverse. If multiple universes exist alongside ours, each with its own set of physical laws, dark matter might be the key that allows energy or information to flow between them. It's a stunning thought: dark matter, so often seen as a mystery, could actually be the cosmic doorway to infinite possibilities. But how does this explain dark matter's elusive nature? If it's acting as a bridge between universes, it would naturally interact weakly with ordinary matter, making it nearly impossible to detect directly. Its presence would be felt only through its gravitational effects, just as we observe in galaxies and galaxy clusters. This theory not only offers a potential explanation for dark matter's behavior, but also opens up a breathtaking new perspective on the structure of reality itself. As we ponder this idea, another fascinating theory emerges, one that suggests dark matter might not just connect universes, but could also hold the key to understanding the very fabric of time and memory. What if dark matter is more than a bridge? What if it's a cosmic record, a form of memory that preserves the history of the universe itself? What if dark matter isn't just a passive participant in the cosmos, but an active recorder of its history? This brings us to a fascinating theory, dark matter as cosmic memory. Imagine dark matter not as a silent, invisible substance, but as a vast, invisible library, a repository of the universe's memories. This idea suggests that dark matter could hold the encoded history of everything that has ever happened, from the birth of stars to the collisions of galaxies. It's like the universe keeping a diary with dark matter as its ink, tracing every twist and turn of cosmic evolution. This theory challenges the traditional view of dark matter as inert and unchanging. Instead, it proposes that dark matter could be dynamic, preserving the events of the universe like a cosmic hard drive. Think of it this way: if the universe is a story, dark matter might be the pages on which that story is written, capturing every chapter in intricate detail. This perspective not only redefines our understanding of dark matter, but also offers a new way to think about the universe's past. What if we could one day decode this cosmic memory, unlocking secrets about how galaxies formed or how the universe expanded? And speaking of redefining dark matter, this leads us to another mind-bending idea: dark matter as a cosmic computer processing the very fabric of reality. But we'll get to that next. What if the universe itself is a massive computer and dark matter is the processor running the code of existence? This is the bold idea behind Theory 23, which proposes that dark matter could function as a cosmic-scale computational system. Imagine every particle of dark matter as a tiny processing unit, working in unison to perform unimaginably complex calculations. These calculations wouldn't just be random. They could be the underlying framework that governs the behavior of galaxies, the formation of stars, and even the laws of physics themselves. This theory bridges the gap between physics and computer science, suggesting that the universe operates like a giant computer with dark matter as its central processing unit. Just as a computer processes data to create programs and simulations, dark matter might be processing information on a cosmic scale, shaping the very fabric of reality. The metaphor here is striking. If the universe is a computer, then dark matter is the processor, and the laws of physics are the software it's running. This idea raises some fascinating questions. Could the universe be running a cosmic simulation? Are the interactions between dark matter and visible matter part of a larger computational process? While these questions might sound like science fiction, they're grounded in serious scientific inquiry. Researchers have begun exploring how information theory and quantum computing could intersect with cosmology, offering new ways to understand the universe's deepest mysteries. But what's even more intriguing is how this theory ties into the next idea. If dark matter is indeed a cosmic computer, could it also be responsible for creating phenomena like time loops? This leads us to Theory 24, where we'll explore how dark matter might manipulate the flow of time itself, bending it into loops that challenge our understanding of cause and effect. What if dark matter isn't just an invisible force holding galaxies together, but something far more mysterious, something capable of bending time itself? This is the heart of Theory 24, where dark matter is thought to create time loops, allowing events to repeat or influence each other across the fabric of time. Imagine a cosmic dance where past, present, and future aren't fixed points but interconnected threads, woven together by the unseen hand of dark matter. This idea challenges the very foundation of how we perceive time, suggesting that it might not flow in a straight line but instead loop back on itself, creating opportunities for events to echo or even rewrite themselves. At the core of this theory is the notion that dark matter could act as a kind of cosmic time traveler, subtly altering the fabric of reality. Think of it like a record player skipping back to a previous groove, replaying a moment in time, or a ripple in a pond that circles back to its source. These loops could resolve some of the most perplexing paradoxes in cosmology, like how certain phenomena seem to defy causality or why the universe appears so finely tuned. Could dark matter be the key to unlocking these mysteries, acting as a bridge between moments that, to us, seem impossibly distant? This theory also opens the door to fascinating possibilities. If dark matter can influence time, could it allow information or even energy to travel backward, creating feedback loops that shape the universe in ways we're only beginning to understand? It's a concept that feels almost science fiction-like, yet it's grounded in the same enigmatic behavior that makes dark matter so captivating to scientists. And as we peer deeper into this idea, we're left wondering, if time isn't as linear as we thought, what other secrets might dark matter be hiding? Now, as we explore this intriguing connection between dark matter and time, another theory emerges. One that suggests dark matter might not just shape the universe physically, but sonically. Could it be that dark matter is in some way a form of cosmic music, a symphony of vibrations echoing through the cosmos, influencing everything from the birth of stars to the motion of galaxies? Let's tune into this next idea and see what it reveals about the hidden harmony of the universe. What if the universe itself were a grand orchestra and dark matter the unseen conductor? This is the idea behind Theory 25, which suggests that dark matter vibrates at specific frequencies, creating a cosmic symphony that shapes the very fabric of our reality. Think of it like this: just as sound waves can influence the patterns of sand on a vibrating plate, dark matter's vibrations might dictate the structure of galaxies and the large-scale architecture of the cosmos. It's a poetic yet scientifically intriguing concept, one that resonates deeply with the principles of string theory, where the universe is composed of tiny, vibrating strings of energy. Together, these vibrations could form a harmonious backdrop, a kind of cosmic music that orchestrates the birth and evolution of everything we see and don't see. And speaking of the unseen, what if dark matter doesn't just shape the physical universe but also touches something even more mysterious, like the realm of dreams? That's where our next theory takes us. What if the universe itself is dreaming and dark matter is the medium through which those dreams take shape? This is the intriguing idea behind the theory that dark matter might be the cosmic dreamer, weaving alternate realities in its sleep. It's a concept that blurs the line between physics and metaphysics, suggesting that what we perceive as reality could be a collective dreamscape, shaped and influenced by the unseen presence of dark matter. Think of it this way: just as our brains create vivid, often surreal worlds when we dream, dark matter might be the fabric that allows the universe to do the same. It's not just inert matter, it could be an active, creative force generating possibilities beyond our current understanding. This theory challenges us to rethink what reality truly is. Are we living in a fixed, objective universe, or are we part of a larger, ever-shifting dream with dark matter as the dreamer? This idea naturally leads us to another fascinating possibility. If dark matter is the cosmic dreamer, could it also be the blueprint, the cosmic DNA that holds the instructions for the universe's structure and evolution? This next theory takes us even deeper into the mysteries of dark matter, suggesting it might be more than just a passive participant in the cosmos. It could be the very code that defines everything we see and experience. Imagine if the universe had a hidden blueprint, a kind of cosmic DNA that dictates how galaxies form, stars ignite, and planets come into being. That's the bold idea behind this theory, dark matter acting as the universe's genetic code, silently guiding its evolution. Instead of random cosmic processes shaping the universe, this theory suggests that dark matter holds the instructions, the very framework that orchestrates the grand design of everything we see. It's like the universe has a built-in plan, and dark matter is the architect behind it all. This concept flips the script on how we think about cosmic evolution. Rather than being a chaotic, unguided process, the universe might be following a set of rules encoded in dark matter, much like how DNA dictates the growth and complexity of life. It's a profound shift in perspective, one that raises questions about purpose, design, and whether the universe itself is part of a larger, intentional system. But here's where it gets even more intriguing. If dark matter truly is the universe's genetic code, what does that tell us about the nature of reality? Could it mean that the cosmos is more than just a collection of random events, but a carefully orchestrated phenomenon? This theory doesn't just challenge our understanding of dark matter, it challenges our understanding of existence itself. And as we explore this idea, another mystery emerges. What if dark matter's role isn't just about shaping the universe, but also about creating illusions? What if it's responsible for phenomena we can't yet explain, bending light, warping space, or even masking entire cosmic structures? That's where our next theory takes us, into the realm of dark matter as the ultimate cosmic illusionist. What if everything we thought we knew about dark matter is just an illusion? This is the provocative idea behind Theory 28, which suggests that dark matter might not be a tangible substance at all, but rather a cosmic sleight of hand, a trick of the universe we've yet to fully comprehend. According to this theory, dark matter could simply be a placeholder for gaps in our understanding of gravity and the behavior of galaxies. Instead of an invisible force holding the cosmos together, it might be a sign that our current models of physics are incomplete, like trying to solve a puzzle with only half the pieces. Imagine the universe as a magician, performing a grand trick that leaves us scratching our heads. Dark matter, in this case, would be the misdirection, the shiny object that distracts us from the real secrets hidden in plain sight. Proponents of this idea argue that what we attribute to dark matter could instead be explained by modifications to Einstein's theory of relativity or other yet-to-be-discovered laws of physics. It's a bold challenge to the status quo, forcing us to question whether we've been looking for the right answers all along. And just as we begin to unravel this cosmic illusion, we're led to the next intriguing possibility, that dark matter might be less of a scientific mystery and more like a form of cosmic poetry, weaving together the universe in ways we're only beginning to understand. What if the universe isn't just a collection of particles and forces, but a canvas for something more profound? Theory 29 dares to ask this question, proposing that dark matter is not just a scientific mystery but a cosmic poet, weaving verses into the vast emptiness of space. Imagine it as the unseen hand that sculpts galaxies, the silent force that orchestrates the dance of stars, creating beauty and meaning in ways we can't yet fully comprehend. This theory bridges the gap between physics and art, suggesting that the cosmos is more than a machine, it's a masterpiece. Think of dark matter as the universe's storyteller, scribbling its verses in the void. Just as a poet uses words to evoke emotion and meaning, dark matter shapes the structure of the cosmos, leaving behind clues in the way galaxies cluster and light bends. It's a narrative written in gravity, a tale told through the invisible threads that bind everything together. This perspective invites us to see the universe not just as a collection of data points, but as a living, evolving work of art. And as we ponder this poetic vision of dark matter, it leads us to one final idea, a theory that takes the concept of storytelling even further. What if dark matter isn't just a poet, but a cosmic librarian, preserving the history of the universe within its invisible folds? This final theory reimagines dark matter as the keeper of secrets, the guardian of the cosmos's deepest mysteries, but we'll explore that in just a moment. For now, let's sit with the thought that the universe might be more than a machine. It might be a poem written in the language of the unseen. What if the universe itself is a story, and dark matter is the unseen hand writing its chapters? This intriguing idea suggests that dark matter doesn't just exist passively. It actively shapes the narrative of the cosmos, influencing how galaxies form, how they move, and even how the universe evolves over time. Think of it as the universe's author, crafting an epic saga on a scale so vast it's almost impossible to comprehend. In this theory, dark matter becomes more than just a mysterious substance. It's the architect of the cosmic stage, setting the scene for everything we see. Without it, galaxies wouldn't spin the way they do, and the universe's structure would look entirely different. It's as if dark matter is the ink on the pages of the universe's storybook, invisible yet essential, guiding the plot from one cosmic event to the next. But what does this mean for us? If dark matter is truly the cosmic storyteller, then every star, every galaxy, and even our own existence is part of its grand narrative. This perspective shifts how we view the universe, not just as a collection of random events, but as a deliberate, interconnected tale. It's a reminder that there's so much more to the cosmos than what meets the eye, and that the mysteries we're still unraveling might be the key to understanding the universe's ultimate story. As we wrap up this exploration, it's worth reflecting on how these groundbreaking ideas challenge our understanding of reality. Each theory we've discussed offers a unique lens through which to view dark matter, pushing the boundaries of science and imagination. And while we may not have all the answers yet, one thing is clear: the universe is far more intricate, mysterious, and awe-inspiring than we ever imagined. As we come to the end of this journey through 30 uncharted theories on dark matter, one thing becomes abundantly clear: the universe is far more mysterious than we've ever dared to imagine. These theories don't just challenge conventional wisdom, they shatter it, offering bold new perspectives on what dark matter could be and how it shapes the cosmos. From the possibility of dark matter forming hidden structures like galaxies and planets, to the idea that it might interact with forces we've yet to discover, each theory pushes the boundaries of our understanding. What's truly remarkable is how these ideas force us to rethink not just the nature of dark matter, but the very fabric of reality itself. The implications of these theories stretch far beyond the realm of science. They invite us to ponder profound philosophical questions about existence, the limits of human knowledge, and our place in the vast, unknowable expanse of the universe. Could dark matter be the key to unlocking secrets about the origins of the cosmos? Or might it reveal entirely new dimensions of reality hidden from our current perception? These questions don't just belong to physicists, they belong to all of us, as curious beings trying to make sense of the world we inhabit, as the famous astronomer J. B.S. Haldane once said, "The universe is not only stranger than we imagine, but stranger than we can imagine." This sentiment captures the essence of what we've explored today. Dark matter isn't just a scientific puzzle, it's a gateway to a universe brimming with possibilities, waiting to be uncovered. And while we may not have all the answers yet, the journey of discovery is what makes science so exhilarating. So, what do you think? Do any of these theories resonate with you, or do you have your own ideas about the nature of dark matter? Share your thoughts in the comments below. I'd love to hear your perspective. And if you enjoyed diving into these mind-bending concepts with me, don't forget to subscribe for more explorations into the mysteries of the cosmos. The universe is full of wonders, and together we'll keep uncovering them one theory at a time. Until next time, stay curious and keep looking up, because the stars and the secrets they hold are waiting.